Hello, everyone. I want to welcome you all to my talk today. The title of my talk is CI/CD Agility and Controlling Pipeline Sprawl. And in this talk, I'm going to get into a little bit about how teams are building software and how the agility of building that software impacts the entire pipeline, and also how to control pipelines that kind of get out of control, either through scale issues or just plain old configuration problems. Before we get started, I want to introduce myself. My name is Angel Rivera. I'm a developer advocate for CirleCI. And in my role as a developer advocate, I'm interacting with the developer community quite often. So when I engage the community, I'm learning about how people are using technology and the many ways that they kind of stumble onto problems with that technology. I'm also, in those conversations, I'm also advising them on how maybe to resolve some of those issues, but I'm also learning how they're resolving those issues as well, right? So it's a kind of two-way, relationship that it's a give and take. But when I'm learning about how folks are using technology, I bring that back to my teams at CirleCI so that we can have real-time intelligence or information and data on how to build better products and features, right, for our community and for our users. And this talk was kind of born out of those conversations, specifically around managing pipelines at scale. So many development outfits, teams, organizations, we tend to start off on projects, right, really small, maybe, an application or a service, and then that tends to grow into something a little bit more complex over time. If we build a system or service that's really popular, as you would imagine, you start to bolt on other services and features, right, to make that service or that application even more useful to customers and users. But what happens is we start adding automation, right, on top of that, especially for our CI and CD processes. And what happens is those pipelines are there, but then they start becoming a little bit more, I would say, complex as well, right? They grow in scale with the project. And then what starts happening is you experience some trouble with especially the CI/CD tooling, right? It starts presenting some obstacles that are kind of inherent to pretty much all types of CI/CD tooling. And that's what I'm going to focus on today, is talking about some of the obstacles people have identified and shown me with our conversations. And I'm going to talk about some of the recommend some of the strategies that you can use to overcome some of those obstacles. So the first thing I want to talk about is the word agility. Like most people, right, we use words often, and a lot of times we don't really understand the definitions, or we think we do, and sometimes we get it wrong, sometimes we get it right. I just wanted to share the definition of agility with you, specifically how it's going to wrap around or at least how it relates to the conversation in this presentation. And basically the definition for agility is the ability to move quickly and easily. Now, with the advent of DevOps and actually the general tech space, right? We developers, operations folks, technology people, we're pretty much under the gun all the time to get software released frequently and consistently. And what I did was I kind of started thinking about agility in a sense of DevOps, right? Or at least technology, in a sense of technology. And I created my own definition. I tend to do that to kind of motivate me to think about things a little bit differently. And I created, or at least I just smashed two words together, which is CI/CD and agility together. And I kind of came up with my own definition to define what it is that we're doing today as developers and as operators within the tech space and within our work processes as well. So what I did was I created this definition of agility. It's nothing new, right? But I did add the word continuously to the definition this time. So my definition of CI/CD agility is the ability to move continuously, quickly, and easily. And I think that's a nice definition of how we actually operate, and it describes agility in the sense that we know it in the DevOps space. So the two things I want to talk about today specifically are pipeline optimizations and then pipeline sprawl. So if you don't know what pipeline sprawl means, or you know, if you don't understand what I'm talking about, I will get into it a little bit, and it's understandable because I did kind of make that up as well. But I think, you know, you'll get the gist of it just by looking at it. But let's go ahead and jump into pipeline optimizations. So these are some of the things I'm going to touch on in my discussion about pipeline optimizations. We're going to talk about resource classes, concurrent jobs, caching, and selective job processing. So let's start off with resource classes. Resource classes, in this sense, I'm using the term to describe all the compute nodes or the compute resources that we leverage in our CI/CD pipelines. Most folks that I talk to have issues with resource classes, and the issues are that they're inadequately sized for the processing, the processing jobs that they're trying to accomplish with those inadequate resources. So one of the things that I always advise folks to do is to actually, you know, take a look at what it is that you're processing, because the goal is to complete these job builds as quickly as possible, so that we can move on to do other things. And one of the arguments I get from folks about, like, you know, adding more resources or paying for more resources to get the job done faster is cost. So if you use a higher class resource compute node, then it's going to cost you a little bit more money. But you have to think about it in a different perspective, which is it may cost you a little bit more money, but it will definitely shorten the duration of that build. So you may be spending a little bit money up front, a little bit more money up front, but because you're completing those tasks a lot faster, because you have the horsepower, right, and the resources to do so, then that should kind of balance out. And in my experience, that is true. Sometimes by, you know, using a higher class resource with the proper capacity, those jobs will finish a lot sooner than one that, you know, has like a lower inadequately classed resource. So, you know, you have to kind of do the math and experiment a little bit. But my experience, again, is that they either cost about the same or less, and occasionally a little bit more, right, by using that higher resource class. Again, and it all depends on what you're doing, right, or what kind of operations you're completing in your pipelines on those resources. So, you know, if your jobs are running into, you know, times that are unacceptable, definitely look at adding a little bit more horsepower, giving your pipelines a little bit more juice or capacity or resources to get the job done faster. Let's talk about concurrent jobs. This is another way to kind of optimize your pipeline builds, right? And when I'm talking about concurrency, I'm talking about running jobs in parallel, right? So let's say you have 3 jobs. You're supposed to run a unit test. You're supposed to do a security scan, and on top of that, you have to package up your application into a Docker image. Now, I work for CirleCI. We are a CI/CD platform, and I do see quite often that people who kind of build pipelines, they're not really optimizing for efficiency. They're generally just putting things together, and some of their pipelines, you know, can take up to, I don't know, 20 minutes, 15 minutes, which if you organize things a little bit differently and, you know, kind of segmented your jobs to run in parallel, you could knock that down by like 75%. So definitely look at the way your jobs are defined and segmented in your pipelines, and avoid any type of dependency. And what I mean by that is, you know, creating some sort of dependency on a previous job completing before you can kick off another one. And that just requires you to kind of analyze your build processes, and then, you know, separate out a little bit of what can run concurrently, and then always identify things that are dependent on previous jobs completing. So again, avoid build job dependencies, because they create blockers in your pipeline that will definitely slow you down. So let's talk about caching. Now, caching is a mechanism that is available in most CI/CD tooling. And what caching does is obviously, right, lets you store things that you use quite often in your builds. The problem is with caching is people tend to abuse it, or they don't understand how caching actually works, or they don't really have good caching strategies. So number one, what I mean by abusing caching is they just cache everything, right? And that also talks to the caching strategies. When I say cache cautiously, I mean, only cache what you need and only the things that need to be updated. So again, just when you're caching, don't cache all the things, right? And only update in your caching mechanisms the things that change. So whenever you run a build and you cache something, you should be able to restore that cache at the beginning of your build and then do kind of an update of change dependencies, which could be like an npm if you're doing Node.js, an npm update or an install on your packages. It will update the packages that have been upgraded and only those packages versus the whole cache, right? And, as we all know, some caching can take up, up to gigs and gigs of data, which actually starts slowing things down, which is something that, you should be looking out for. Now let's talk about selective job processing. This is kind of a term I use to kind of describe picking and choosing, right? How to run specific jobs when you're processing them in your automation tools. One of the biggest kind of blockers I would say that I've identified in pipelines is the testing execution processes, right? So what I mean by this is if you're running testing processes in your pipeline, make sure that those tests are actually something that you absolutely need in your pipelines, right? One of the things that I see quite often is folks are just running test suites and specific tests that are very, I would say, comprehensive and take a lot of time in your builds. And quite honestly, when I look at what they're doing, their pipelines are segmented maybe for a development or QA type process or segment, and it's not going to go into the production or staging process until a little bit later on. But they're running these monster test suites that are consuming quite a bit of time. So basically take a look at what you're running in your test execution segments and make sure that they're useful, right? Because when you're running these tests and you're building software at certain stages, right, in your pipeline, there's things that you don't really need to run all the time, or at least you don't need to run them at specific times. If you can push them off to a more I would say, a segment of your pipeline further down the road, definitely do that, right? Because that's where it's going to matter when those test results kind of come to. If you're just developing early on left of the pipeline, these things really occasionally, or in most cases, don't really need to be run at that specific point in time. Look into conditional job execution. What I mean by that is being able to pick and choose, right, the segments in your pipeline at the appropriate times. Like I mentioned earlier, maybe you have a development segment in your pipeline where you push some new code. It runs a few processing jobs on that code, and then jumps into maybe segmenting into a deployment, into staging or Q&A. And you can definitely do conditional job execution on that, and that will help you kind of orchestrate how your pipeline proceeds and also save time on processes that you don't need to run, right? So think of it as a kind of a parsing of your pipeline to organize it in a way that will make sense at the appropriate stage of that particular build. The next thing I wanted to talk about was setting target build durations. And what I mean by that is, as I mentioned earlier, maybe you have an application that takes about 15 to 20 minutes to build, and it's composed of a couple job segments in your pipeline. What I recommend you do is set a limit on how long a job should run, right? So it's almost like a goal for the most part. I generally use a 1-minute build target. So I want all of my jobs to complete within 1 minute. Now I know it's, really hard. It's a really hard kind of goal to achieve 1 minute and almost unrealistic in some cases, but that's okay. Because that's just the goal, right? I'm always aspiring to be 1 minute and under in my builds. And yes, there's always outside factors, like if you're deploying to a cloud provider, obviously, depending on the service you're using, depending on the cloud provider and how responsive they are on the back end, will dictate, right, how long that deployment will take. So again, right, just set a target and always strive to achieve it no matter what. That keeps you, at least should keep you with, your optimization in mind, trying to be efficient in everything you do within your pipelines. Again, it's just kind of like a little, we all set goals for certain things in our lives. 1 minute build jobs for me is a goal. So let's do a quick recap on the pipeline optimizations that I was talking about. Look at resource classes, make sure that you're adequately sizing your compute nodes so that you can get things done quicker. Again, if it costs you a little more, it might actually be cheaper in the long run to execute these commands on these higher class resources, because again, the jobs will finish a lot faster. Concurrent jobs, obviously try to avoid build job dependencies, right? Those are blockers that will slow you down in your build processes. And cache cautiously, right? Only update the things that need to be updated in your cache. And also, keep an eye on the size of your cache. That could also impact, your build times. Selective job processing. Look at how you're executing tests. When you're executing tests, make sure that it makes sense to execute those tests at specific stages of your pipeline. Also look at how your pipelines are running, right? So create or at least analyze them for conditions and make sure that you're running them appropriately at appropriate times within your pipeline and your processes. So now that I've covered pipeline optimization, let's jump into pipeline sprawl. And what I mean by pipeline sprawl is basically when you have automation, CI/CD automation and pipelines that start to become unmanageable, right? Either due to increased volume, increased repositories, or the files that govern your CI/CD tooling have also grown in volume, which I'll get into a little bit here shortly. So the first thing is, in most CI/CD tooling, most modern CI/CD tooling, pipelines are now controlled using what we call configuration as code. And those configuration as code syntax, they live in a configuration file. Now, generally speaking, this is a ratio that's kind of more common these days in software development, and most teams operate in this manner. Of course, there are exceptions, right, to the rule, but in general, for the most part, most of the teams that I speak to and organizations I speak to, they run their operations in this manner where they have one code repository and one pipeline configuration file within that code repository. So it's a 1-to-1 ratio for the most part. And generally speaking, those configuration files are actually defined in what we call a YAML syntax. And if you know anything about YAML, most people don't, unfortunately, but they consider YAML to be like a programming language. And I'm here to tell you that YAML is not a programming language, and it shouldn't be considered that way. Even though it has that declarative smell to it, some products use it to kind of program things or configure things. It's definitely not a programming language, so don't treat it as such and don't consider it as such. YAML is a data structure. It's like JSON, right? So I don't want to kind of say that they're exactly the same, but obviously, right? It's a data structure just like JSON is a data structure with the obvious cosmetic syntax differences, right? But basically, when you have YAML as a data structure and you're feeding that into your CI/CD systems, what happens is YAML doesn't have any kind of reusability to it. It does have a very small, like anchors, right? You can create a little bit of reusability, but values cannot be varied, right? So the syntax then becomes redundant because all you're doing is cutting and pasting new syntax, and you only needed to change one value in that, right? New command within the YAML. So again, the syntax can be redundant, and then that creates a growth in complexity within the file. So if you're cutting and pasting the same data elements within YAML all throughout, your configuration file will grow astronomically, right? It can go from like 100 lines of configuration to possibly tens of thousands of lines, right? I've actually seen that in some customers' configuration files. So when you have that problem, right, now your file or your configuration for your pipelines becomes really, really hard to navigate and manage. Which is a place you don't want to be, right? CI/CD pipelines are very critical to our software development practices, and when you're in that position where your configuration files are, really, really long and almost hard to manage, it becomes an even bigger problem, right? That you need to solve. So there's also this scenario where not only your configuration file may have like thousands of lines of syntax in it, you can also be in a situation where you have maybe hundreds of repositories, right? So remember my ratio, right? 1-to-1, one repository per CI/CD configuration file. And that creates the pipeline sprawl that I was talking about, right? So it could be defined in two different ways, but at the end of the day, it's still sprawl. And again, that becomes difficult to manage. And I can tell you from experience, it's a real headache when you have hundreds of repos, and then within those repos, you have to update maybe an S3 upload command, right? Imagine 100 repos with 100 config files, and maybe inside of that file, you have another 10 calls. So that's quite a bit to update. And that creates a configuration kind of repo dilemma, right? Like, so what do you do to combat all of this stuff? And occasionally, in speaking with folks, I hear the solution could be GitOps, right? And then after looking into it, looking at the GitOps kind of concept, I found that the GitOps is not really a viable solution, right? Like, there's elements to it that could help, but it's not really an end-to-end all-in-one solution to solve this pipeline sprawl that I'm talking about. One of the things I can tell you that helps is don't hard code commands within your YAML. And I'll give you an example of that, which is sitting right here. As you can see, this is coming, I ripped this right out of one of my pipeline configurations for one of my projects. And if you look at the command key there, all I'm doing here, right, is just uploading a simple, application jar to S3, so it's available for some other processes. Now, imagine if I had that command listed in maybe once in 1,000 configuration files in 1,000 repositories, and I had to change that, right, for every single project. Try doing that manually. It's going to take you quite a bit of time. You could also automate this, right? Like, you can create a script to kind of search for that text and replace it. But then how do you automate or how do you validate that your automation is correct, right? You're going to have to build automation to validate your automation. And then that leads you down like a huge rabbit hole, right? Because then you have to automate the automation or validate the validator for the automation, right? So you can see where that kind of starts getting trippy. But what are we talking about here, Angel? What are some of the options that you recommend? I can tell you, after thinking about this problem for a minute, I started looking at it as a developer, right, and said, all right, well, this is simply an engineering problem. So one of the first things I started to do was create a separation of concerns, right? I implemented object-oriented programming principles, and again, just created a separation of concerns. first thing I did was I looked at common pipeline patterns, which is something you should do as well. Look at the patterns that are always happening. So in the example of uploading S3 or files to S3, right? That's a common pattern that's probably littered throughout a bunch of your configuration, pipeline configuration files. So once you have those patterns identified, go ahead and create abstractions, right? Isolate them. And then when you're creating the abstractions, obviously you can encapsulate that functionality and some of the parameters and values that are required by that pattern. And once you have that, you can then again, create that encapsulation, isolate that functionality, and then create parameterized values or variables for certain values within that functionality. And that creates that reusable modular effect that you're looking for to kind of, keep your code succinct, keep it centralized. And what I'm proposing here is that you build pipeline libraries, right? So once you have all of that encapsulation done and the patterns kind of identified, you can then build these pipeline libraries. Now, some CI/CD tooling already kind of affords some of that, right? They have the features to do that. But what I can tell you is the stuff that I've used in the past, though it is available to you, they kind of dictate the language that you should be using. So, it could be something like Groovy or some other domain specific language that the vendor or the project maintainers have built for that specific project. And those help, right? Those are fine. But what you really want to be doing is something like this, where you're, creating either shell scripts, Python scripts, whatever language, right? You shouldn't be locked in. I'm a firm believer in just giving developers the opportunity to get their jobs done with the tools that they are I guess the tools of their preference. Sometimes it's not feasible because of technology stacks, right, that clash. But in general, you should be able to write scripts like this. So let's jump into this example. And this is the kind of an upgrade to the example I showed you earlier where I was hard coding things within my commands. It accomplishes the same tasks. But what I'm doing is I'm just separating things out into scripts, right? So now I have this, if you look at the command line at the bottom, I have this s3 uploads.sh file, which is a bash shell script. And what I'm doing there is just putting that functionality to upload into S3 into that script. And now I'm just, swapping out the variables and the values for the parameters. And this will give me a nice central way to manage all of that code, right? So if I have to make any changes, it's going to be done in one location, right? It's going to be done in that script file. And then that change will propagate over to all of the configurations that are using that script. So once you have that capability built in, right, in your scripting, you also have a way to kind of resist or prevent or minimize vendor lock-in, which is what I was talking about earlier when you're hard coding things, right? Let's say, today you're using, some other vendor for your CI/CD needs, and you decide, wow, CirleCI is awesome. I want to switch our team to that. It's a little bit better for our team to use. Once if you have everything hard coded, it's going to take you a lot of time, depending on the amount of configurations and repos you have, to kind of take that pipeline and define it as something useful within CirleCI. Now, if you already had this scripted out in these kind of pipeline libraries that I described earlier, it shouldn't take you much to populate your new CirleCI configuration file with calls to those scripts, right? And then obviously there's going to be some customization or that are specific to specific tools, but that will be very minimal, right? Configuring that will be very minimal compared to having to just plug every single hard-coded bit of your old configuration file into this new system. And by the way, this will also help you with moving it to another system. Let's say God forbid, CirleCI is not the best choice, which I highly doubt that'll be the case. But if it is, then you can move on to another vendor and have very minimal configuration problems. So just keep that in mind when you're building out any kind of functionality. You definitely want to kind of keep those abstractions at a higher level, and then also maintain your scripts and your functionality encapsulated in those abstractions. So one of the things I wanted to mention at CirleCI, we actually solved this problem by creating what we call orbs. And what we've done is on the back end of CirleCI, we created parameterized YAML. So like I mentioned earlier, domain-specific languages, it's kind of like that because YAML is a data structure. So we created a way to parameterize values within your YAML files. And one of the things that happens there is the backend, will be able to kind of parse out the parameter keys within your configuration file, and then also give you the ability to manage all of that functionality in a central location. And that's where the orbs registry kind of comes in. So when folks are building orbs, which is just, again, repeatable modular pieces of CirleCI CI/CD configuration, those things are managed in a central location, which is what we call the registry. And it's almost like an NPM package management or Docker hub, where everything's kind of stored online in these repositories. We have the same thing at CirleCI. And also, we have a lot of partners and vendors and we share a lot of customers. So, customers are using certain tools within their pipelines. We actually have a ton of partners that have written orbs so that our users can easily implement that functionality into their CI/CD pipelines really, really easily. So let's go do a recap on pipelines and sprawling pipelines. So first thing you want to do is identify your common patterns in your pipelines, encapsulate that functionality into parameterized scripts, and then use those scripts to consolidate and centrally manage code. And again, this will help with minimizing that vendor lock-in and definitely will add a ton of portability to your CI/CD pipelines. And that's pretty much it for my talk. If anybody wants to have a conversation with me afterwards about this, it's best to hit me up on Twitter at the bottom right corner there. My Twitter handle is @punkdata. So yeah, if you want to discuss this or anything else, just hit me up there. And I want to thank you all for showing up.